there, Amir here. I am creating a playlist to run you through the basics of some of the most important data structures. A lot of the companies, like the ones in the FANG or whatever you want to call them, MANG, really require you to have a deep understanding of data structures. It's not like you can just get some ChatGPT code and run with it with a lead code problem and think that you will be able to tackle an interview with Meta as an example. So I'm going to start talking about linked lists. It's a very simple concept, but it can get in your way if you're not really grasping the elements inside a linked list. So let's do that together. Before we do that, I would really like to ask you one thing. If you haven't already subscribed to my channel, please do. It really helps me grow my audience and build more quality videos for you for free. So let's jump into this one. When I was thinking about teaching linked lists, I was looking for a very good example. What I did think of was treasure hunt. Imagine you have been given a map. The map tells you where the money is. So the first part of the map says that if you go to the kitchen, what you will find is the treasure, which is a very small amount, but it's still $5 for free. The next thing that is really important in this treasure hunt is a clue for the next part of the money. And this is very important, right? You find a $5 and you want to find another $5 or maybe $50. So the beauty is that it tells me, hey, if you want to find the next part of this money, I want you to go to that bedroom. And this is super important. You have told me that the next part of this treasure is inside the bedroom. So this is the bedroom according to the map. And there is some treasure here as well. And this time it's a bigger treasure, it's $10. And the clue is a bit of this money is inside the garage. They have hidden it in the garage, which is great. Now I understand where the next part of this money is. Now, once I have that covered, I will move into my garage. And if you bear with me, this is going to really make sense very soon. So I go to the garage, and this is the garage. There is a treasure of $20. It's going up and up. And the beauty is that there is a next clue. It actually tells me that, hey, there is not any more money left. You are done. You have found all the money. Go and get yourself some meal. Now, what I want to do, I want to translate this into code. You might not really be familiar with object-oriented programming or classes within Python. Think of it as the backbone of your linked lists, which is very important. I'm just going to call this a list node, which it is. This is the definition of a list node. And I'm going to define it as init of self and value initially equals 0 and next is none. I will explain what this actually means in a second. But for now, what I will show you is that the self of val equals val as you go on, and self dot next equals next. And you might say, hey, Amir, look, it doesn't really make any sense to me. Well, let me show you. A list node really means that there is a node that is identified by two specific characteristics of that node. So for this node that we call, there is the value of the node. That's what we were writing as self.val. And the next one is the pointer, where it means what is next. So if this is your node 1, what is next? So the next attribute of a node is where it is headed, or the pointer. We call this the pointer. This is a very important concept in understanding linked lists and list nodes because they are identified by two things, a value and a pointer. So let me just write down linked lists. And you may ask, hey, Amir, what does it really matter? Why are we using linked lists? Why are we not using lists or arrays or other data structures? Well, for starters, this structure allows for dynamic resizing because what it does, imagine you have got a linked list with 3 nodes, right? Like this. I don't care what the values are inside. And you have a second one. So a second one looks like this, and it has got only 2 nodes. What you can do with linked lists is that you can change these pointers and you can say, I want you to first point to this one. Then I want you to point to this one. Then I want you to point this one. And then I want you to point to this one. Now you have successfully merged this into a new linked list without having to create a new empty list node and adding values to it. This is very powerful because it's very memory efficient. That's what we call dynamic resizing. So maybe number 2 is you can say that you can have efficient insertions. So you can insert data very easily, and you can have efficient deletions without really needing to copy a lot of data. So these are the three things that I can think about. But I know that there are so many other benefits to linked lists. Now that we have gone through the theory, let's just write this back to the code with how we define a class of list nodes. What I will do, I'll just clear the screen and we will go back to coding. So let me run this. Now that I have defined the list node, I'm just going to follow with the example of kitchen, bedroom, garage, $5 in the kitchen, $10 in the bedroom, and $20 in the garage. That's what I'm going to do. So I'm going to say the kitchen, as we discussed about it, has got a list node of $5. So kitchen has got $5 in it. Let me print kitchen, and you can see that kitchen is a part of a list node. So that's great. And if you recall, we knew that bedroom had the amount of $10 in it. Oh, I missed the equal sign there. All right. And the garage had the amount of $20 in it. So I will run that and I will delete this one. Now you may say, hey, Amir, you said that there is a node and there is a pointer. So I believe that this is the node. Where is the pointer? That's a very good question. Once you clearly say what the list node's value, because this is what we did, we have already captured the value. Now it is time to talk about the pointers. For us to talk about the pointers, we only have 2 pointers here. Let me tell you why. Because you have got the kitchen that points to the bedroom, and the bedroom points to the garage. Well, does the garage point to anything? No, the garage points to none because there is nothing there. So literally, we're not going to be talking about that pointer. So that we can assume does not exist for now. So this is your pointer number 1, and this is your pointer number 2. If I were to draw the pointers now, so the kitchen dot next is the bedroom, which is very good. Now you understand that, okay, that's what the pointer is. Kitchen is pointing to the bedroom, and bedroom dot next points to the garage. I made a dictation mistake. And you can see that now kitchen points to the bedroom and bedroom points to the garage. What also really helps decipher what a list node is. So if you look at that kitchen, right, and you look for the value, you can see that the value for kitchen is 5. This is what we were trying to say as well, wasn't it? And if you look at kitchen.next, you will see that it is pointing to somewhere in the list node, which is very... This brings me to another area that you really need to understand about list nodes. If I were to, again, reiterate what we said about nodes, each node has a value and it has a pointer, right? So it has 2 specific parts. For example, in the example for the kitchen, so if you're looking at the kitchen node, the value is $5 and the pointer is pointing to the bedroom. Now you may ask, hey, how do we connect to list nodes? If I have this by itself and I have another one here, how do I connect them to each other? Let me show you. I am going to use a different example to show how to link to different nodes. So if you've got a node here by itself, it's not connected to anything, and you're calling it your first node. And if you have another node here by itself, not connected, and it is called the second node, you may wonder, how do we connect them to each other? Let's say the first node has got the value of 5 and the pointer is none, right? Because it's just by itself. It's not connected to anything. And I'm just going to call second, the value is 10. And the pointer is also none because it's not connected to anything. So let's create them in Python. In Python, I'm going to say first equals list node of 5. That's what I said. Second equals list node of 10. And if I were to print the value of first, you will see that the value of first is 5. And if I print the next of 5, the pointer, it will say there is no pointer. The same goes to second.val. It should print 10. And if I look at second.its pointer, it is also none. So they're not really connected. How do I connect them now? I think it's very easy, right? I have to add the second as where first.next points to. So if I say, hey, I want the pointer for the first, that's what it is, first.next, to point to the second, all right? If I do that, and if I print first.next again, you will see that now it is not none. Previously, when I did print it, it said none. But this time when I did print it, it has some pointer direction, which is very good. So what happened when I had the first and I had the second, and both of them had their own values and their pointers. Now the pointer here was none in the first, right? What happened now, when I started pointing that at the second, we have deleted this, and now it says second, which is very good. That's what you were seeing in the code. What you should know now is that we have connected the node from the first to the second. So this one was the first and this one was the second. Both of them have got two sections. Here is the value, here is the pointer, which is the next. This one also has got a value and also a pointer. And this one in reality is pointing to none, that we will see. Let me show you how now I have chained these two nodes together in Python. What I will do, I will start with a new variable and I will set it to first. Because what I want to do, I want to take the first one and traverse across to the second one and jump out of the other end. That's what I want to do. If I do this, and I show you print current.val, you will see that it starts with number 5 because it is sitting at node number 1. So let me show you. I have set the current to look at the first. This is the first. And now I'm going to move it to the second because I did look at this number 5, which is sitting here. Now I want to move it here, and this one is the second. Let me show you. What I will do, I will set the current to second. And if I print the current.val, you will see that I have 10. I have moved my pointer to this node now, and I'm going to move it across to the outside of ListNode. Let me show you. So if I go current.next, set this to my current, and if I print current.val, you will see that, hey, there is no val because it's a none type. If I show you the next here, you will see that, well, current really doesn't have any next. But if I print the current, you will see that current itself is a none, and that's why we were getting that weird value. What I want to do at the end is to give you example number 3 to really go through how we create a list node and why it is important to start from the very first node all the way to the last node. So I will call node 1, and I'm going to say, hey, node 1 is a list node, and the value is there, and the value in there is 12, right? Now, node 2 is also a list node, and the value is 24. Obviously, they're not connected yet, but what I can do is that I can say node1.next equals node 2. This way, now I have connected the two nodes together. If I wanted to add a third node, I will call node 3 is a list node of 36. I just want to make them really distinct. And node2.next equals node 3. This way now I have connected the third node. If I were to quickly write this with this command, what I am saying is that, hey, I want you to have a value of 12 inside node number 1. With this command, I am creating another node and I'm putting the value 24 there, and it's node 2, but I haven't yet connected them. There is no connection, there's no pointer there. With this command, I am adding this pointer, or the connection between node 1 and 2. With the next command, I am creating a third node, which is this one, and the value is 36. And with this last line, I am creating this next connection or pointer. All right, I hope this video helps you. I spend a lot of time thinking in preparing my videos, and I really appreciate if you subscribe to my channel, hit the like button, and leave a comment if you have any questions. Also, feel free to connect with me on LinkedIn. I will leave my LinkedIn page down in the description. Ask me any questions and let me know what you want to see in this channel. Thank you very much and good luck.